If you look at this question is asking what is the integral here. Is it okay? So integral I will be equal to x into sine x. I'll write like this into secant x into secant squared x, right? Secant x into secant squared x. So I is equal to integral of x into sine x. That secant x can be written as 1 by cos x into secant squared x times dx. Now your sin x by cos x will become equal to tan x, correct? Tan x into secant squared x dx, right? Secant squared x times dx. So now what we'll do, we'll put tan x is equal to t. If you put tan x is equal to t, differentiate with respect to x. What do you get when you differentiate with respect to x? Secant squared x dx will become equal to dt. So this implies x will be equal to tan inverse of t. Tan inverse of t. So your answer I here after substitution will be tan x will be equal to t. So tan inverse of t into t, tan inverse of t into what is it? Dt, correct? Now this is nothing but u into v rule, u and v. The choice of u and v is made as per the rule, what is it? Isolate, right? Isolate. First comes inverse function, that is u. Then comes algebraic function, that is v. So we can write I is equal to u into integration of v minus integration of differentiation of u into integration of v dt, the whole dt, correct? The whole dt. So what is your answer that we get? I is equal to tan inverse of t into t square divided by 2 minus of integration of 1 divided by 1 plus t square into t square divided by 2, correct? Into t square divided by 2 times dt. So I is equal to tan inverse of t into t square divided by 2 minus of t square. This is 1 by 2. I'll add plus 1 minus 1 divided by t square plus 1 times dt. I'll add plus 1 minus 1. Okay, in the numerator. 1 plus t square, I'll write it as t square plus 1. No difference. Tan inverse of t into t square divided by 2 minus of 1 by 2 integration of 1 minus 1 divided by t square plus 1 times what is it? Times dt, correct? So your answer to the question I is equal to tan inverse of t into t square divided by 2 minus 1 divided by 2 into t. Integration of 1 by t square plus 1 is nothing but tan inverse of t plus c, correct? Plus c. So your answer to this particular question I is equal to tan inverse of t into t square divided by 2 minus of 1 by 2 times t plus 1 by 2 times tan inverse of t plus c, correct or not? Plus c. So what will be your answer here now? If you take out tan inverse of t common, what remains in the bracket? If you take out tan inverse t common here, we are left with t square by 2 plus 1, t square divided by 2 plus 1 by 2, correct? T square by 2 plus 1 by 2 minus of t divided by 2 plus c, correct? So what is this answer that we get? Tan inverse of t into 1 plus t square, okay, divided by 2 minus t divided by 2 minus of t divided by 2 plus c. So I'll solve this problem this side. You see here, what is this tan inverse of t? Tan inverse of t is nothing but what? Tan inverse of t is nothing but x from here. Tan inverse t is nothing but x into 1 plus t is nothing but tan squared x divided by 2 minus of tan x divided by 2 plus c, correct? I is equal to x into secant squared x divided by 2 minus tan x divided by 2 plus c, correct? So I is equal to x secant squared x minus tan x plus 2c whole divided by 2. I'll write like this, plus c divided by 2. So if you look at the options, the options given are something like this, right? The option given is like this, 1 by 2 into x secant squared x minus tan x plus c. This will be the answer to the question.